हो और ये आपने कोई कोई एक रेजोल्यूशन का टेस्ट रेजोल्यूशन शो हो रहा है जिनमें क्लैरिटी नहीं है ये पहले वो ये दूसरा संता है ना जितना ज्यादा तो क्या होएगा अब हमारे इसका रेजोल्यूशन
Good afternoon, participants, different centers. I hope that if you'll be having, we are here to reply all those queries. With us now, Dr. A. Ramesh from who has taken a morning session, and yesterday afternoon he has taken one session. Then Dr. D. S. Khatri, he did a PhD from IIT Delhi, and now he's having his own R&D organization. So he's with us with Professor Benwet. Just I'll wish to convey for 5 minutes in what way, when you have conducted the experiment, what way that write-up has to be. The example of this one presenting in front of you. In NIT Jaipur, when I was last year, in that case, the class size is more than 100 students. If 100 students you are having, the theory part as well as practical part, the tutorial, everything is with you. So lecture you are taken in the class, going in the laboratory. In laboratory you are having 20 students, a group of 20 students you are having. So for 100 students you are having 5 groups. So what I was doing when we were conducting experiments, first of all, these type of programs when we were invited industry people as a panelist, we have taken input from them also, that what are their expectations from the students which are coming out from the foremost weakness which they are conveying to us. The students are very weak as far as practicals are concerned. Hands-on working part is concerned, they are very weak. And the secondary part is their presentation skills, their communication skills, that's secondary thing. But as far as their basic knowledge is concerned, their contents are concerned, their experimental capabilities, they are very weak. So foremost thing is, because IC engine subject we are taking, we let that in what way our laboratory component has to be strengthened so that confidence level of the students can be increased. And even the writing part also. These days students, they have forgotten writing. Even the writing which they are doing in the form of SMS messages, that language they are using. Their writing skills have become very weak, very weak. So what I was doing in the lab, just for 3 hours lab we are having, out of that one I was keeping for this experimental purpose only 2 hours 15 minutes. So conducting experiments for 2 or 15 minutes, the possible way of conducting the precautions, everything, taking help from technicians, everything, that part was there. Then in 2 or 15 minutes, everything we have done, calculation part, everything we have done, and results, everything we have checked. Then I asked to the students that in these 2 or 15 minutes, whatever you have learned, you please come on the board in front of the students, you please present in 5 minutes. So that presentation part also means the hesitation students are having, that hesitation will be removed. So for 5 minutes to every I used to give. So within some 45 minutes, 8-9 students used to present whatever they are 2 hours and 15 minutes. That is their confidence building part. Then for writing, I said don't write anything here. Even don't write that from manual etc. Just formula from here. The way you have conducted the experiment, just you understand that one. What exactly you have done, it should be understood to you. So writing part, you go home, do there, and in the form of a research paper you write. The way we are writing the research paper, first of all we are writing objective of the research paper. Suppose the example I have written here, carburetor design for a spark ignition engine. Just carburetor experiment we are doing with load, how air fuel ratio is varying, these type of experiments when we are. So I said you will be writing objective of that one, then the name of the author, everything we have written, abstract of this experiment, you write out abstract of that one, then introduction part, and go on Google related to this experiment, whatever literature is available, books, journals, everything which is available, you try to go through in what way other people have conducted these experiments, what were their conclusions, like that one. So introduction part you write in the form of a research paper. Then after writing research this introduction part, go on that will be literature review also, and then you go on actual experimental setup, the drawing of the experimental setup, go in AutoCAD software or any other software, you put that experimental setup there. Then the observations which you have made in the form of table. You please put those observations. Then finally come to the results and discussion. You plot graph everything in your this software. After writing results and discussion, write conclusions of this one. After conclusions, you write the reference you have taken, help from that what help you have taken, and you mail to me. So for one experiment, 100 students are there. I used to get 100 mails, and in one semester we are conducting 14 experiments, 13 experiments. So number of mail which I was receiving, those were 1300. I used to check every mail. Just I'll be showing you this part which I checked here. Say in Word there is a facility to write the comments. Basically in review when we are going, we are to write comments. So abstract which you are written, after assessing this abstract, I have written comments about this one, that this abstract should be in such a way, some changes should be there, like that. The comments I was writing here. Mine comments, I used to send it back to students. The mail I was sending back to the student, and even grading also I used to do there. References, in what way the references should be written, what more addition to the references, everything, whatever the comment I was writing there, even grade I was giving, and I was sending back to the student. So like this one, when this writing they have started in the form of research paper, even some of the students in 4th experiment, 5th, 6th, they have started to give suggestions that in place of doing this experiment, if it would have been done like this one, it would have been better. This same experiment setup would have been used like this one. Some of the suggestions were coming, and some of the students even they have presented these papers in also seminars also. At some of the events when it is being organized, even inter-institute, the institute, some of the papers have been published also. So this way, if you are doing the experiments, they are their in-depth learning of the experimental setup, everything, that will be much more clear. In this case, lot of pain will have to take. If 1400 mails you are taking and you are sending back after putting your comment, it's a rigorous exercise everyone has to do. So, but if you want to improve our students, want to improve their confidence level, certainly these innovative, these exercises will have to do. So with these, I will be moving to my own place, and we are ready to give answer of your queries, because from industry side, Dr. Khatri is there, from research organization, Dr. Ramesh is there, basic side I'll be answering. So we hope that 1.5 hours time or 1 hour 15 minutes time, many of the questions were there, many of the will be there. Even you can ask what are the areas in IC engines where the research activities can be started. Thank you very much.
Presentation on how to write a report, and in fact before we start the session, let me introduce that we have Professor Ramesh from IIT Chennai. In the morning session we have listened to his expertise on different IC engine topics, and we have listened on the first and the second of Dr. Punia, who is a well expert and well known personality in the IC engine. And from the industry, we have Dr. Khatri now with us. So these three are the experts today available. We'll start the panel discussion. In fact, I like that some questions were raised in the morning session by some institute to Professor Ramesh, which we didn't answer it, saying it's a lunch break. So first, I'll request Dr. Ramesh can take up some questions from the respective institute on the topic. Then we can start the panel discussion. I think that will go. So. इसको शिफ्ट कर दो।
आओ मिनट साहब आगे इधर आ जाओ।
तो इसमें नेटवर्क बंद हो गया ना, मगर फिर भी वो बाकी इसमें मगर
चलो उनको कोई नुकसान नहीं हो रहा है।
So, sorry for the interruption, operator at our end. So again, now we are connected in Institute. Okay. So now database is connected, no? Yeah, we can have a question from database.
This is from Sukhuri.
Yeah.
Good afternoon, sir. I would like to know the status of LPG as out of fuel. Is it safe, or is there any research being done on this? of fuel in some other countries also or in India?
From which this is what.
So LPG is which has been used in automobiles for a long time, and here also Dr. Khatri is also working with automotive industry for using LPG. So in fact, in countries like Italy, I think Canada, even in India, there are a lot of vehicles running on LPG, and the network is well established. And LPG is also for spark ignition engines. So it is, I think it has even gone to the research stage. It is being widely implemented. So it's at that level. Maybe Dr. Khatri can.
Even Maruti Suzuki first vehicle which was on gas was a Omni LPG, and it was launched in around 2002. So LPG is a very good fuel for spark ignition engines, and it is cheaper than petrol. That's why advantage with LPG is like you can travel a long distance in one filling because it's liquid form. CNG is in gas form. So LPG technology is well established. Earlier LPG Omni was using carburation system, but now LPG system has been introduced. And in WagonR also we have introduced on petrol as well as on LPG. So it is well established fuel, and there is problem related to the safety. It is as safe as gasoline.
Some experiences about LPG I wish to convey. First, LPG is mainly propane and butane, and calorific of LPG is just like gasoline, which is more or less equal to gasoline calorific value. Octane problem which is coming because I have done research work on LPG and diesel basically in dual fuel. In winter it is creating problem. It is vaporization in winter becomes very difficult, and when we are taking this cylinder, even the vaporization temperature of propane and butane is different. So of propane is there, then in last butane remains in the cylinder, and combustion characteristics of propane and butane is something different. So when I was doing research on this one, partly the combustion characteristics which were coming, those were something different because earlier only propane was coming. Then second time in the bottom of this using spark ignition engine, then it won't work efficiently. For this dedicated engine, spark timings, everything according to this LPG has to be adjusted, and then it should. Otherwise, it's safe. There is no problem. Flammability limits, everything is wonderful. It is quite high, around 700 degrees Celsius ignition temperature it is having. So no chance of any accident if it is there. But because it's gas, safety measures has to be when we are ending, because inside the cylinder pressure is around 13-14 bar. So ending at that higher pressure, it has to be precautions has to be taken.
I hope this answers your query. Now we can have one more question before I shift to the other institute. Yes, Sukhmani. Sukhmani Institute, we can have one more question from your institute. So no question coming up. I can take up another question now from Graphicera University. Graphicera University, there are no. Graphicera University.
Graphicera is not met.
So we can have from TTC Jodhpur one question. TTC Jodhpur. TTC Jodhpur, we can have a question from your end. Yes, any question?
Are you able to listen? Please respond. TTC Jodhpur. Are you able to listen?
So they are listening but not responding.
Respond करेंगे, respond करना है, पैसे लग रहे हैं गवर्नमेंट के भाई, पूछना है हमको क्वेश्चन. Are you able to listen at TTC Jodhpur?
सब माइक ऑन कर लीजिए अपना.
माइक ऑन करें.
जीटीसी जोधपुर माइक्रोफोन ऑन कीजिए, म्यूट पर है आपका माइक्रोफोन। जीटीसी जोधपुर।
They are unable to listen, I think, no? Another center, you please.
Yeah, we can take up MMU Mulana is there?
अपन पहले ना उनको वो कर सकते हो, आर यू कनेक्टेड, आर यू लिसनिंग अस।
MMU Mulana. MMU Mulana. Are you able to listen? MMU Mulana.
अपना own है क्या?
रेड आके बंद होते हैं।
इसको बंद कर। ये लाइटिंग कैसी है? ओके, और अपना तो चले, अपना ये तो चले साउंड सिस्टम तो पूछेंगे कैसे?
Okay. Yeah, now IIT बद्दल
नहीं उनको भी तो सुनाने हैं हमसे कौन तो बनेगा, उनको भी चलेगा ना, सबको जोड़ना है।
let everybody listen. Otherwise वो जो वीडियो कॉन्फ्रेंसिंग हो नहीं सकता है।
ये वापस ऑन नहीं हुआ है, इधर ऐसा हो रहा है। एक बार ऑन हुआ।
Hello. We have 24 rupees a model.
शायद वीडियो से तो ये वैसे तो
So we have a question here from Harun Rajasthan. We have no USB in the classroom.
Yeah, TTC Jodhpur. Jodhpur.
Hello?
Yes, please continue.
Yes, please.
Yes.
Yeah, TTC Jodhpur. Your question to the panel. TTC Jodhpur. Your question to the panel.
What I was saying is that LPG technology is. Hello?
Yes.
Please continue.
We have started using LPG as a fuel, but there are problems. First, hello?
Yes.
There are problems persisting because of excessive gum formation. Gasket gets damaged. Hello?
Yes.
Yes, you ask your question.
Yeah. Because of use of LPG, gum formation takes place, and this gasket gets damaged
Which gasket?
prematurely.
Which gasket? Which gasket?
Cylinder head gasket.
No, I think we have run around 80,000 vehicles of Omni LPG and we have not faced any problem. Number one. Number two, if some there is a tendency the peoples are using domestic LPG instead of auto LPG. If that is the case, then we face little bit problem from the market, that is a corrosion in the cylinder and the pipeline. Corrosion problems were reported because there may be a moisture in that and filter may get choked due to that.
Yes.
And that is mainly because the people, because domestic LPG is subsidized, so they are transferring
It is a single filtered fuel, I think, and that is double filtered.
Auto LPG quality is different. That is more clean and it has the less sulfur content, and secondly that is having good octane number, and that should be only recommended. But the tendency, the people that are using the domestic LPG, they are transferring the domestic LPG from the domestic cylinder to the auto cylinder. So that is a big racket actually. It is a big mafia is there for that. Anywhere between Delhi to Jaipur, if you are going, you can get a domestic LPG cylinder and you can get filled your tank. They are using some small pump also on the road, and whenever you don't have the LPG, you can get it from the roadside. So that is
it was so earlier. It was so earlier, but now this domestic cylinder is available for 1,200 rupees. So nobody is using it now. Nowadays, I think.
So these problems are not also there. If you are using the auto LPG, there is no problem because fuel is designed and manufactured according to the SI engine requirement. Auto LPG, not domestic LPG.
Right.
Okay.
Thank you.
Another question from TTC Jodhpur.
No question from TTC Jodhpur? No question?
Jodhpur only.
Pardon? Any other question from Jodhpur?
Any other person interested? Please.
Why no? Why no? We people are speaking last 3 days, and from speaking part from your side is coming. You are saying no. It should be.
In the scratch, you have explained the basics, and for the advanced stage, Professor Ramesh has taken up, and you have explained all these things in such a brilliant way that I don't think there will be any more questions. If somebody has paid attention to your lecture, then anything and everything is self-explanatory.
That's very good. That's very good. But because many queries has to be in 3 days, we can't explain whole IC engine. So remaining part of IC engine, because Ramesh ji will be for 50 minutes here only, 45 minutes. He'll go. He won't be. Then we will be unable to catch him. No, years it will take to catch him, and I think again we'll have to repeat the same history. And same is the case of Dr. Khatri. So it's very difficult to catch these people, very busy people. We people are very lucky that they are with us. You ask as many questions you people can ask. There has to be queries. If you want to go for research, many queries has to be in 3 days. Some things we have conveyed, but those were very small issues. Now many of the issues should come out from your side.
then advantage of these type of courses will be. If it is one-sided only, just like one-way traffic, there is no use. Please come up with many of the questions.
We were clearing queries in the middle also with Professor Ramesh.
Okay, that's good, wonderful. Okay, please take up another center. Yes.
So now we'll take up another center. MMU Mulana. MMU Mulana. MMU Mulana. Please put some question to the panel.
Can you hear me?
Yes.
Yes, you have taught many ignition system. There's one word used on Ford diesel engines, TDCI. Can you explain that term?
TDCI, these are all terms like CRDI, DCI, DICOR. So this is also one more term. But all of them mean common rail injection systems. They are all direct injection engines with common rail. These are all terms that these companies give to their products.
Their own brand.
Their own brand, yes. But it is only direct injection common rail.
So any other question?
From my side, Dr. Sitaya.
Yes, please.
Please continue.
Can we have supercharging or turbocharging in the existing system?
No, it is in the existing system. If we use a turbocharger, we may damage the engine because the pressures and temperatures will be very high, and the normal engine may not be able to withstand unless it is already over designed. But there are engines which, with the same block, they can go to different levels, and such engines can be turbocharged. But normal engines, I don't think they can be turbocharged because it may damage the engine.
Okay. So,
Please.
Minimum? No, when we want to turbocharge an engine, there will be many changes that you have to make, and these may not be very simple. If we want an efficient turbocharged engine, we may have to make changes in valve timing, manifolds, then injection timing. All this may have to be changed, and it will not be a simple task.
okay, so now we'll move on to another institute, Graphic Era University. Graphic Era University.
Yes, I have one question on supercharging. Hello.
Yes. Please go ahead.
Hello.
Yes.
My question is that there is a loss of the power at high altitude,
Okay.
and so that is compensated by the turbocharging.
Okay.
So is there any relationship? What is the relationship between the loss of power to compensate how much is the turbocharging which is required?
Actually, it is easy to calculate because ultimately we have to know only the mass of air that goes into the engine. So you can use very simple calculations to determine the mass of air. Basically, if you take a turbocharger compressor, you can assume that the compression process is isentropic. That means it follows PV power gamma equals constant. And from that you can calculate the density. And once you know density, and if you know the cylinder capacity, you can know the mass of air that goes inside. And you can compare this mass with the mass which will go inside at atmospheric conditions. And you can find out how much it will compensate. You should know that when we say that a turbocharger compensates for loss in power, it is in comparison to a non-turbocharged engine. If you take a turbocharged engine which is running at sea level, and if you take it to high altitude, it will also suffer some loss of power.
Okay, any other question?
I was just wondering if we cannot use hydraulic coupling in the turbocharging.
Hydraulic coupling. Hydraulic coupling, basically, as you are aware, hydraulic couplings can be of two types. One is hydrostatic and the other one is hydrodynamic. And hydrostatic is only for slow application, so it is not suitable. Hydrodynamic also will have a lot of losses, and it is not for the speeds at which a turbocharger runs. So this is too high a speed, and I don't think it is possible to use hydrodynamic coupling as well, because the speeds are very high, and we normally don't use oil and all at that speed.
Okay, thank you. Thank you, sir. Now we'll move to other institute because there are many institutes and I'm restricting at least 2 questions to every institute. So now Arya Engineering College, Jaipur. Question from Arya Engineering College, Jaipur.
Yes, sir. There is a question from me that we are using turbocharged assembly basically in diesel engines.
Yes.
But turbocharged is used to improve the volumetric efficiency of the engine. Why we are not using this in the petrol engines?
If you really recollect the petrol engine lecture which you saw, petrol engines are susceptible to knocking. You will find that if you raise the temperature of the charge, the engine can go into knocking, and if you supercharge an engine, the temperature will go up, so the engine will easily knock. So if we supercharge an SI engine, it will be knocking, and if you want to avoid knocking, we have to reduce the compression ratio, and if we reduce the compression ratio, efficiency will be bad. So turbocharging or supercharging as such is not advisable in the case of normal SI engines, but in the case of GDI engines, it is definitely advisable. Maybe Dr. Khatri wants to.
Yes, Dr. Ramesh has rightly mentioned that generally if you see in the market also, you will not find petrol engine which are turbocharged or supercharged because of it is creating knocking, and secondly in earlier date it was a carburetor mode and it was more complex phenomena, but in GDI we can go for the turbocharging to take the advantage of the extra air. And for that we have to design the engine, we have to redesign the piston so that connecting rod, so that they can take care of the extra load and extra combustion pressure which is created due to the supercharging. So diesel is much better option, and most of the engines they are designed to take that extra pressure. And with turbocharging, I think power improvement is 20 to 25% or like that.
Right, it can be even more.
Maybe minimum from 20 to 30% or 35%, and that is we call nowadays downsizing of the engine. It means from the small engine we can get the more power.
Increased pressure means increased size of the engine, and we will lose the advantage of having smaller petrol engines.
No, increased pressure means not big engine.
Strength of piston, so that it should be able to withstand more pressure. It will increase the size and bulk.
Not in bulk. This is in millimeters. If you are suppose the thickness of a normal petrol engine, the top thickness is around 5 millimeter, and if it is turbocharged, it will be 7 millimeter. So it is not making 2 millimeter does not make the size bulk, but we call it downsizing of the engine.
Lead to increased power of 20%.
You get to maybe 25, yeah, 25-30%, yes.
So this will be in vogue for the future.
Yes.
Thank you.
This technology.
Now we are moving to NIT Kurukshetra. Connected. Okay. So the next institute I'll take up IIT Baddal. IIT Baddal. There were questions earlier also from IIT Baddal. We have not answered. IIT Baddal.
Hello.
Yeah, IIT Baddal.
Hello. Hello.
Yes, sir, we are listening.
Hello. Hello.
Please ask.
Yes, sir. Hello. Sir, I am Adarsh Kumar speaking from IIT Baddal Engineering College, Ropar.
Yes, your question.
My question is.
Yes, please ask your question.
In Indian market, there are n number of types of fuel available for the various types of vehicles. For example, petrol and diesel having different cetane and octane number. Are they competent for all types of vehicle having different design aspects?
Basically, like in petrol, suppose we have a 85 octane number fuel available, 87 octane number fuel available, even we have 90 octane number fuel available. Earlier, we had the lower compression ratio engine. Say the compression ratio, if you look back 10 years, it was around 8.5, 8 to 8.5 compression ratio. Nowadays, the engines has the compression ratio of around 9.7, even up to 10 maximum, between 9 and 10. So it is changed by 1. That demand more octane number and less, and it is unleaded also. So if we are putting the good fuel, even in lower compression ratio engine, it doesn't make any problem. Right? Suppose if you are using the 90 octane number in an old car, so it will not cause any problem. But if the new car, it may take lower octane number, that may cause some sort of a knocking and all that. That is regarding the petrol. And in cetane, I think Dr. Ramesh may highlight.
I think most of the time, even in the case of petrol, if you, I don't know whether they are asking about different grades available, like the speed and the normal petrol and all that. I think apart from the octane number, there are other additives also, which they put in the petrol, which can be useful in making the system clean, or maybe spark plug for avoiding spark plug fouling and all that. So these are also some of the other benefits which you may get from the higher premium grade. Now, one more thing is, as we were seeing in the morning, if the engine has a knock sensor, that is KNOCK knock sensor, then it can adjust itself to the octane. Suppose you put a better fuel, then it can change the spark timing so that it can utilize the potential of the better fuel. On the other hand, if you do not have this knock sensor and if you have an older engine, maybe it cannot really make use of the better fuel that we put. So it all depends on the vehicle also. But as Dr. Khatri rightly pointed out, if you take an old engine, if you take a new engine and put a low grade fuel, definitely the engine will suffer. So it much depends on the kind of engine we have, and the normal fuels are good enough. I think the higher grade fuels are not really required unless we have specific.
Okay, another question.
Thank you, sir. My second question is.
Not at all.
Sir, please बीच में मत पूछिए क्योंकि दूसरे सेंटर से क्वेश्चन. हाँ जी, IIT Bhadal, you can continue.
Sir, my second question is, in turbocharger, in the second lecture we have heard about that 2 lakh RPMs. So with which instrument we can measure these 2 lakh RPM?
You have rightly identified the problem. In fact, in a turbocharger, it is very difficult to measure speed because normal instruments do not work. So even the manufacturers have they many times use even optical probe. They use a light probe, and the turbine wheels or the compressor wheels, as they cross this light probe, the reflected light is picked up. So they use even fiber optic probes and all that. So it is difficult to measure speed of the.
So now we'll move on to Riyad Bara Real Majra. Riyad Bara Real Majra, please put your question to the panel.
Thank you, sir. Thank you.
Riyad Bara Real Majra.
Riyad Bara, you can ask the question.
Riyad Bara, are you listening?
Please respond. Sir, switch on your mic, please.
Riyad Bara?
Your mic is off.
Lakshmi Devi Institute, Alwar. Lakshmi Devi Institute, Alwar. Lakshmi Devi Institute, Alwar, you can put your question.
Lakshmi Devi Institute. Sir, you can ask your question.
Lakshmi Devi Institute.
Please respond if you are listening.
Lakshmi Devi Institute. Lakshmi Devi Institute, please put your question.
Sir, all are listening but not responding.
Hello, if you are listening, please respond. Please say, are you listening me?
Lakshmi Devi Institute, are you listening us?
Hello? Hello, yes?
अभी लेंगे, बाद में लेंगे वापस आपको.
एक्चुअली कोऑर्डिनेटर वहां पर है. Riyad Bara, if you want to ask question, you can ask. सर ये बैठे हैं Riyad Bara. बोल ही नहीं रहा सर कोई.
Are they listening?
Sir, they are listening but he's not responding. Pusa Polytechnic, you can ask question. Hello, Pusa Polytechnic. You can come near the laptop and ask the question.
Hello.
Hello.
Yes, please. Ask your question.
I am speaking from Graphicaro University, Dehradun. My question is on the that in case of the two-stroke engine, it suffers from the drawback of the exhaust emissions, and it is also possible to why not to have a fuel injection system in the two-stroke engine and to use a catalyst to remove the exhaust.
In the two-stroke engine, as you have problems because of short circuiting of the fuel, and which means that in the amount of fuel that is short circuited is quite considerable. It will be something like 20% of the fuel. So 20 to 30% of the fuel comes out through the exhaust. Now, if we inject the fuel into the cylinder after the ports close, yes, we can avoid this short circuit. But the problem is, two-stroke engines are meant to be cheap and simple, and that is why they are popular. And if we put a fuel injection system on them, they become expensive, and the whole idea of the two-stroke engine and its simplicity is lost. I don't think people will buy unless it is a large engine. So in small two-stroke engines, fuel injection systems are ruled out because of cost factor. Otherwise, definitely it will be advantage.
No, but since the cost of the fuel is also increasing day by day, and what I just wanted is that at least for the research purpose, at least one such engine should be and such a prototype should be made.
Yeah,
so that we have the technology ready with us.
Yeah, actually for research purposes, two-stroke fuel injected engines are available. Even in our lab in IIT we have developed. So these engines are with injection. Only thing is they are not very cheap, but the technology is available.
No, even I add on this, even two-stroke engine in three-wheeler with injection system technology by Orbital, it was launched in the market by Bajaj 4 years before. And yeah, and I think they have sold around 30,000 vehicles, but it is not gaining popularity because of the Dr. Ramesh has said the cost is more. And the advantage in fuel economy, that is around 1 or 2 kilometers per liter. So that is not sufficient, and sometimes even that is not there. So it is not successful. So Bajaj has launched 4 years before Orbital injection system technology in their two-stroke engine, but it is not accepted by the market.
What about the use of afterburner?
See, now let me ask questions from my audience which are present here. then we'll again come to the defense. So questions from my audience.
यहाँ से पूछो, इधर आके
वहीं से जोर से बोलो।
नहीं, दिखोगे नहीं और आवाज भी इधर से आएगी, या जोर से बोलना जिससे आवाज उनको सुने आपका क्वेश्चन।
What is the scenario of Wenkel rotation? Is there any scenario regarding that?
Yes, sir, please.
So this Wankel rotary engine is not popular in regular automotive applications, but it has got some specific advantages. First is that it has a very high power to weight ratio. So it is good for certain applications like aircraft. That is small aircraft, remotely piloted aircraft. So it is being widely used in remotely powered aircraft, and even in our country, I think they are trying to use. So it is there in that field, but it is not there in let us say regular automobiles. It is not so economical, and it's not very efficient. Its main advantage is its high power to weight ratio, no vibrations. So such things are the main advantage.
Well, since I think I know that regarding this Wankel engine, Wankel rotary engine, the GM Motors of US has done a lot of the work on this rotary engine, but they have found and they have left these efforts on the way.
Yes.
Reason being two, that it was very poor in the exhaust emission, and number two, its fuel consumption was also quite poor as compared to the existing other engines.
Yes, you are quite correct.
Actually, its main advantage is that it is a high power for a given weight, and that's why it is being used in the manless aircraft. And even Indian military and Air Force already they are using this Wankel engine in their aircraft.
In Navy they are using.
In Navy also they are using.
For surveillance.
Surveillance.
Another question from the audience.
What is the stuff going on this use of crankcase ventilation? Is it being used as a vehicles or just as a studio only?
Crankcase ventilation. PCV. Yeah, actually, if you see Fiat and Ambassador, at that time you have a blowpipe, and that is all the fumes, blow-by gases, they are emitted in the environment. Now, I think since 1997, it was banned, and we are recirculating this, and we call it positive crankcase ventilation system. Like, so whatever the back pressure is there, that is again sent to the combustion chamber. So that is there. But now, even till now, it was good. People say, okay, we are avoiding the blow-by gas emissions and all that. But recent research, they show that your oil quality, that is deteriorated due to this. And now again some research work, this is again a research area now, that we can do like what is the best, because there you are affecting the environment. And if you are reusing that, because that fume gases, they have some contaminant which is in the oil and all that, and they are coming and going back to the combustion chamber. So they cause more wear and tear, and they damage the quality of the oil also. Global.
Any other question? Yes.
How can we recover some hydrocarbons?
Please wait, we are asking.
आ रहे आएंगे, TTC आएंगे, अभी आएंगे, जोधपुर आएंगे, बिल्कुल आ रहे हैं, अभी आ रहे हैं
obtained from water by hydrolysis. They have been developed by Honda, but they are not commercially available right now. What's the reason?
First reason is that highly explosive. That can be used by accident. What the papers are saying.
But they have developed this.
That but that is highly explosive. When
Are
it
there
can
any
be passed from anti-national elements, they can this.
Actually, hydrogen actually is, of course, as you said, Honda has developed and BMW has developed, and even in our country, Tata Motors has also worked, and Mahindra has also worked on hydrogen. So basically, as a fuel, they know how to use it, but as it was rightly said, it is highly explosive, so handling and all that is a problem. But still, where is the hydrogen? That is another question. The main question is the availability of hydrogen. Electrolysis of water is a source, but for that we need electricity. And the amount of energy that you need to split water to get hydrogen is quite enormous. And so it is not economical to use normally generated electricity. If you have abundant source of hydroelectric power, or if you have a lot of nuclear power which we are not able to use, then only producing hydrogen may be economical. Otherwise, there is no economical way of producing hydrogen on a large scale now to be used as a fuel. And then we also do not have the infrastructure to safely handle it, distribute it, and use it. So these are mostly technology demonstrator projects. They have the technology.
Now, even in India, we have started a mission was formed, that is Hydrogen Mission 2020. Under that, it is planned that in India we should have minimum 1 lakh vehicle operating in the road by 2020. And in that context, we have started some research work also, like Mahindra, the Tata in IOC. And now, regarding the availability of the hydrogen, there is a one pilot filling station. I don't know whether you know or not. It is put in Delhi, in Dwarka. There we are producing the hydrogen with the electrolysis of water, and it costs 450 rupees per kg. 1 kg hydrogen costs around 450 rupees as compared to 70 rupees kg of gasoline. Of course, 1 kg of hydrogen is equivalent to around 1.7 liter of petrol in terms of calorific value and all that, because calorific value of hydrogen in terms of kg is almost very high. It is more than I think around double, around 100 megajoules per kg. So this is one thing. Now another route which India has adopted now, that we are blending the hydrogen with the CNG. And some pilot vehicle, around 100 vehicles are running in Delhi with the blend of hydrogen and CNG. And the purpose of that pilot station is to provide the blended fuel to the bus and cars which are operating as a pilot test. And we are using a blend of around 25% to 20%. That is a blending. So it means directly at this moment we cannot switch on to the hydrogen, because number one, infrastructure is not available, fuel itself is not available, and secondly, engine technology is also not very matured. Because I give one example. Suppose we are using an injector. So in injector we limit that leakage should not be more than 0.1 cc per hour. Okay. The same injector if I am using for hydrogen, the density is very low. So the leakage may be 10 times more than the in case of CNG. So it is disaster, and we are using some sensor hydrogen detection and all that. So it is to be matured. Even Honda and all that, they have demonstrated the technology, but it is in a nascent stage. So it may take some time till we get the, because maybe after 5 years petrol cost maybe 200 rupees and hydrogen maybe, then it may make sense, but not now.
One more question. Now Tata Motors is also working on
in India, more than 1 megawatt is generated through captive power plant.
Please hold on. There is a question to be posed to our audience. Please hold on.
We'll be coming back.
We'll come back.
So we are working joint venture with some country on compressed air vehicles running on compressed air. So what is the scope of
This compressed air vehicle, we are also doing some work, and we found that compressed air as a fuel, I mean not a fuel, as an energy carrier, I would say, as an energy carrier is sometimes attractive. It is not so viable, and maybe in some applications it is viable. Otherwise, how do we get the compressed air? We have to use a compressor. Again, we need electricity, and if you take all this, of course, yes, it is in some respects better than the battery, because it's like a battery only. You use electricity and store a battery. Here you use electricity and store a cylinder with compressed air. And you now have to compare the size of the compressed air tank and the volume of the compressed air tank and weight and all that with the battery. You find that if you compare them, the battery is better. But then if you compare them on the life basis, the battery has to be changed after 3 years. Maybe this tank may come for 10 years or 20 years. So this is the kind of comparison. It is still not very clearly demonstrated that compressed air is better. There is, as of now, I would say maybe battery as an upper, and maybe in some areas maybe compressed air.
Distance covered in one capsule, one cylinder compressed, that is very low. That is around 40 kilometers. Even the battery can cover around 120 kilometers. So that is another major disadvantage.
With all that, we calculated. We calculated with lithium. Actually, we made a comparison with compressed air and all these batteries. If you compare it with nickel cadmium, compressed air is better. If you compare it with lithium ion, lithium polymer, these batteries are better. But if you compare the cost of lithium polymer and all that, then again they are comparable. But if you compare the life of lithium polymer and that compressed air is better. So they are somewhat in competition. But the battery has some advantages because it is quick in responding and things like that. So that the compressed air tank.
The pollution part, if you consider in the batteries.
No, disposal. Disposal is the main problem.
Because toxic material, lead acid batteries, if you are having acid is a problem, lead is a problem, that's a severe problem, and many of the batteries we are receiving from developed countries also. Recycling is being done in Delhi itself. It's a great news. So recycling of batteries are.
And in 3 years you have to change the battery anyway.
Yeah, last question from our audience.
आगे 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 ये आवाज जाएगी नहीं आपकी वहाँ पे दूसरी जगह जल्दी से फास्ट.
My question is that why hybrid engines are not gaining popularity in the market?
Hybrid engines are why they are not gaining popularity.
Hybrid engine or vehicle?
Vehicles also just like a Honda Civic that costs only 20 lakhs, but the actual model coming in it costs 60 lakhs. But only the difference is 4 lakhs, but that vehicle is not sold very much. What's the reason behind this? We are all talking about another solution for the fuel, but the hybrid engines are available. Why are not getting the popularity?
If you look at the hybrid vehicle, actually, see, there is one is hybrid vehicle also has a battery. That is one problem. The second thing is hybrid vehicles are complicated than the conventional vehicle. But the upside is that it is more efficient. No doubt about it. It is more efficient. But if you look at city driving, maybe it is useful. If you look at highway driving, hybrid and ordinary vehicle are almost the same. Because in a hybrid also in highway conditions, the engine only will be powering the vehicle. And in the city or in a car also, engine will be powering the vehicle. So it depends on the operating mode also. If you're operating within the city, maybe it makes sense. And that expense, is it comparable is what is the question.
Yes. Actually, that is the main reason because the Indian market is very cost sensitive. Initial cost as well as the running cost of the vehicle. When you are increasing the cost, the Civic you have given right example, it costs maybe around 14 to 15 lakhs, normal Civic, 14 lakhs. Hybrid is 20 lakhs. So then customer will calculate, okay, if my average improvement is 2 kilometers and I am investing 6 lakhs rupees extra. 6 lakhs rupees interest is around 10,000 every month. So is it giving me back? No, it is not giving me back. So it is a cost. If you can launch the hybrid 14 lakhs and 14.5 lakhs or 15 lakhs, then it may make sense. But 5 lakhs difference is quite good. You can get another car in 5 lakhs.
Another example I am giving. I have purchased diesel car Swift Desire. I paid 37 lakhs. My colleague has purchased Swift Desire petrol. He has paid 6 lakhs. 1 lakh difference was there. I asked why you have taken petrol. Petrol is very costly. He said why it is costly. It is not costly. 1 lakh rupees I am paying extra. Interest of 1 lakh is 12,000 rupees per year. 1,000 rupees per month. It is not the cost of the extra cost of the petrol. And I am not going anywhere on the highways. I am just using 4-5 kilometers per day. It hardly matters for me. Petrol is more comfortable. Yes, maintenance is lesser. So he has calculated like that one. So initial cost as well as the fuel running cost, then running cost, maintenance, everything, everyone is calculating.
Thank you. Now we'll again come back to the USA Polytechnic. I think they wanted to ask a question. USA Polytechnic. USA Polytechnic, your question.
Hello, sir, USA Polytechnic.
Yes, ask your question.
Sir, we want to know about Wankel engine. Wankel engine, rotary engine. Sir, we want to know about Wankel engine, rotary engine.
Yes.
Hello, sir, Wankel engine.
What can you be more specific because you want to know the principle of the you want to know what the Wankel engine is. Is it so?
Yes, sir.
Okay.
Yes, sir.
Wankel engine is basically a rotary piston engine, and it has a piston which is actually triangular shape. You can say it is approximately triangular in shape, and it runs in a very complicated passage, and it has a complicated gearing. But then the advantage is that it is rotary. It is not reciprocating. So inherently you can completely balance the engine, and it has got 3 for one revolution of the rotor, you can get 3 power strokes. So it gives you higher number of power strokes per revolution of the engine. So it is a compact engine, but it has got other problems apart from the complexity of manufacturing. The problems are sealing. It's a rotary piston, so it's very difficult to seal, and its combustion chamber is very long, and then it has problems of emissions, it has problems of knocking, it has problems of friction, even cooling, continuous cooling, because it's very difficult to cool that rotor. Problems in manufacturing. The advantages are in high power to weight ratio, no vibrations. These are the advantages. So wherever these advantages are very, very important, people go in for the wagon.
Yeah, any other question? Uttar Polytechnic?
Sir, about Stirling engine also, sir. Sir, solar Stirling engine.
Yes.
Solar Stirling engine.
The solar Stirling engine, or whatever the Stirling engine.
We want to know why it is not used.
No, it is used.
Not being used. Solar Stirling engine.
Yes, please. The solar Stirling engine is used in many places. It is used in places where you can focus the energy on that Stirling engine's heat exchanger. So it is possible to use, but the Stirling engine as such is not very powerful. It is bulky, so it is not definitely suitable for mobile applications. But there are people who are trying it for mobile applications. I have seen a couple of models also, but still they are not popular because invariably they are bulky, and they are good only for solar energy applications or waste heat applications and things like that. But the main problem is only it is bulky. I don't think, and it's too many mechanisms and all. Otherwise, it is okay.
I would like to add on solar Stirling engine. Last year we have put 3 solar Stirling engine in Gurgaon. It is a ONGC, but it is again for power generation. It is a 5 kilowatt engine. One engine is 5 kilowatt, so 3 engines has been put, and the efficiency is around 22% of these engines. But as Dr. Ramesh has rightly mentioned, the size is bulky because the size of the solar collector is very large. So now we are exploring the possibility of usage of Stirling engine in the waste heat recovery, especially in bus and trucks, because there you can use the exhaust gases temperature, because the operating temperature of Stirling engine is around 400 to 450 degree temperature is required, but it is not commonly used. That one engine cost around 6 lakhs rupees as on date, 5 kilowatt. So it doesn't make any commercial sense as on date.
Okay, thank you. Now I'm again coming back to the other issue.
Hello, sir.
So, TTC Jodhpur, you can have a question from TTC Jodhpur.
I was asking whether these NOx sensors are being fitted in today's vehicles.
हाँ
सर ग्राफिकेरा में अपना माइक म्यूट कर लीजिए.
हेलो
Hello.
TTC Jodhpur.
Right, sir.
You
I
are
was asking whether these NOx sensors are being fitted today in vehicles.
In advanced vehicles in luxury model these are fitted, yes, but not in Alto, WagonR. They are not fitted as on date. But in advanced vehicle like Honda Civic, Toyota, like NOx sensors, even in SX4 they are fitted.
Okay. Thank you.
Any other question? TTC Jodhpur. So we can have a question from RA Engineering College, Jaipur. RA Engineering College, Jaipur.
Hello. I have one question there. From TTC, I am speaking from TTC.
Yes, please.
Yes. सर जनरली ये अपन फाउंड करते हैं, ये जो हैवी ड्यूटी जो डीजल इंजन व्हीकल्स है, इसके अंदर जो ट्रक एंड बसेज हैं, इसके अंदर जनरली मतलब फैन बेल्ट टूटने की वजह से पिस्टन सील की जो प्रॉब्लम होती है, तो जो ड्राइवर की जो डिपेंडेंसी होती है वो उसके थर्मोमीटर पर होती है. तो इन व्हीकल्स के अंदर ऑडियो अलार्मिंग सिस्टम अपन क्यों नहीं यूज कर रहे हैं? इससे क्या कॉस्ट बढ़ेगी या क्यों नहीं यूज किया जा रहा है? फैन बेल्ट इज ब्रोकन. Audible?
Yeah, it is audible. It is audible.
There is no warning system, audio alarm system. So we are not using such system.
And this is most essential in commercial vehicles because the driver is not too educated.
Actually, when if the fan belt broken, because the water pump is driven by the fan belt, and there are even 2-3 fan belt. Even the alternator is also driven by the fan belt. So whenever the fan belt broken, if it is a water pump, then the engine temperature will shoot up. So there is a visual indication in the dashboard. The temperature will shoot up, but there is no audio. And it may be provided. Yeah.
It should be provided because once the driver is driving on a highway, he is not able to see all the visual indicator. So there should be an audible warning signal. What should be done on this?
Yes.
No, this your suggestion is good and may be passed on to the OEM.
Hello. Thank you, TTC. Now we can have a question from RA Engineering College.
Hello, sir. I am from RA Engineering College.
Yeah, your question, please.
Sir, till now we are able to attain the efficiency of IC engine about 50 to 55%. What is the recent research to attain the maximum efficiency of IC engine?
I think 50 to 52 itself is you already got the maximum.
You divide it by 3.
So
yes,
you have given already given a very big target for people to reach. I think they have reached 52. You are right in saying
only in special cases.
In very special cases like large marine engines,
yes,
it is possible. Two-stroke marine diesel engines, it is possible. But if you take automotive engines, I think they are hardly working at, I have seen maybe maximum of 40%. And beyond that, it is very difficult to go. So that is the level. The reason is they have to meet so many other requirements like emission norms, drivability and all that. So when we put all these together, it becomes very difficult to get very high efficiency. Because even if we make it very efficient, people may not like it because they will use other things. On the other hand, in the case of marine engines, stationary engines, people are not interacting with the engine, so they can make it very efficient.
Even a recent concept like in Germany, in Japan, it is a CHP system. Like small engine, in Germany it is mandatory now that every house may have minimum 10 kilowatt of in-house generation with CNG. So CHP means combined heat and power. So in cold countries, the efficiency of the system may be around 80% because you are using the waste heat to heat the water. So there the overall efficiency of the system, because you know that significant amount of energy is wasted by cooling water and exhaust gases. So that heat energy is utilized in cold countries, and that can be utilized in India also in the case of power generation. But in automobiles, again people are working on waste heat recovery.
So repeat your question, please.
Air density.
So you are saying that air density, if we increase in diesel engine, then the calorimetric efficiency and power will be increased.
No, you have to. You will put more air and you have to also put more fuel.
Okay. The same phenomenon we use in petrol engine. The ratio, air fuel ratio, remains 51 increase, 30 ratio 1. Efficiency will increase or not?
No, but you cannot increase to 30:1 because in SI engine you have to maintain the air fuel ratio in a small range. So even if you increase air, you also have to increase fuel. Both will be increased. Only increasing air is not enough. So air, if you use a 3-way catalytic converter, you have to use only stoichiometric mixtures. So you have to maintain the air fuel ratio.
Any question from Riyaz Bada?
Graphic arrow. Okay, we can have a question for Rafi. Yes.
My question is that if the country is working on alternative fuels, the India is also quite comfortable in producing of the alcohol. So why not to have the alcohol engine completely rather than having being used as an extender? Alcohol about 5 to 10% is being used as a fuel extender. I wanted that it should be a completely alcohol fuel engine.
Even we are not able to get alcohol to substitute 5%. This is done only in few part of the cities, because then farmer, they say it is not available. They start increasing the cost, and calorific value of alcohol is around 50% of the petrol. So you have to consume more, almost 1.8 times more fuel as compared to gasoline. But that is not the case. But the important thing is it is availability of the alcohol. In Brazil, alcohol is available and people are using 100% M85. That is readily available. But in India, availability of alcohol is a question mark.
Another thing regarding this alcohol, no, basically it is coming from sugarcane industry, and there is a strong lobby of sugarcane industries. When the question of this mixing of even 5% came, that time cost of the petrol was around 45 rupees per liter, and cost of the ethanol was 4-5 rupees per liter, even less than that. And when question of mixing into petrol came, then that strong lobby which was holding this alcohol production, they have increased this cost to around 62 rupees per liter. In 50 rupees petrol, if you are mixing this alcohol and that to 5%, how that person, the refinery people, they will be purchasing. So it was a difficult task. Then another interview, I listened interview from Ram Naik sir. He was that time petroleum minister. So some Patrakars were asking that why you people are not using this ethanol as a neat fuel just like Brazil. He said we don't have faith on this drivers, sir. They will drink. They will drink. So, but foremost thing is alcohol is not available. Ethanol is not available. Even the industry people who are having ethanol, they are not ready to give this refinery.
And even that they are selling at maybe 200 rupees per liter in bottle.
Yes, that's again, yes.
Why they will sell at cheaper, that is the...
So, you can have question from other institute. Any institute want to raise question?
Any question from Riyad Bhara?
Hello. Hello.
Yes, sir, we are listening. You can ask.
Hello.
Yes, sir, ask the question.
Hello. My question is from Professor A. Ramesh. He stated about the matching of the characteristics for the turbo supercharger, turbine and compressor characteristics.
Yes.
So in case the characteristics are not matching,
Okay.
then what will happen to the operation?
If the characteristics are not matching, many problems could occur. For example, if the turbine is not able to produce the required torque required by the compressor, the pressure ratio will fall. You cannot get the required boost. This could be one problem. If the turbine produces more power than the compressor requires, the pressure ratios can become very high and the engine also can get damaged. Or sometimes if the speeds are not matched properly, the compressor, I showed two margins. One is called the surge margin and the other one is called choking margin. The compressor can get into the surge margin, and if it gets into the surge margin, the compressor could even get damaged after a long time. So we could have many problems if the matching is not good. And some of the problems will be immediately seen, some of the problems could be seen, the result could be seen only after a long time. So matching is very essential for proper functioning of the turbocharger.
Any other question? Yes. Riyad Bhara, any other question?
Hello. Hello.
Hello, Hanji.
Sir, is there any alternative being developed to the reciprocating engine combustion engine anywhere in the world?
Alternative to reciprocating. Alternative to reciprocating engine.
Yes, sir. Alternative to reciprocating a internal combustion engine being developed.
The alternative to reciprocating engines, people are, I don't think there are any effective, that is viable alternatives today. And in fact, it can be debated and people can come out with alternatives. But the one of the alternatives, as we were discussing, is the vacuum engine. The other alternative could be the gas turbine for certain applications. But there is no alternative as of now to completely replace the ICE engine in all its applications. So one has to really look for it, and we find that the IC engine as such already has reached its limit, and even alternatives may be only just that good, unless they are going to drastically change some concept, which is not seen so far. People have come with alternatives like using reciprocating pistons directly to produce electricity. That is, they have a piston which is oscillating and a coil which is surrounding the piston, so that directly the piston becomes the moving part of a generator, and the coil is the stationary part of the generator, and they generate electricity. So these kinds of things are already in practice. These are not really completely different engines. They are still reciprocating engines, but that doesn't have a connecting rod. It doesn't have a crankshaft. So there are such developments also taking place. But a complete alternative, as of now, I don't think is available.
Sir, we never talk of inertial losses in internal combustion engine. Are they very insignificant?
Sorry, inertia?
Please repeat.
Sir, we never talk of inertial losses in internal combustion engine.
Yes.
Because it's reciprocating. Are these losses very insignificant?
No, actually, if you, I am not very clear about what you mean by inertial losses. Actually, inertia.
Losses from inertia, because the parts are reciprocating. They have to move, then stop, then again move.
Actually, if you see, inertia cannot lead to any loss, because unless there is some friction or something like that, there can be no loss. So the reciprocating parts of an engine, even though they have inertia and they produce forces, there is no loss. But you could have vibrations because of this reciprocating. And if you can properly balance these vibrating forces, it is possible to completely avoid them. But inertia as such, I don't think can produce any loss. It can only produce changes in torque, it can produce fluctuations in torque, vibrations, but it cannot produce any permanent loss.
Sir, engines in the new car, like Swift.
Yes, please repeat.
Sir. Hello.
Hello.
The engine in the new car is having very shorter stroke length.
Yes.
Very shorter stroke length. Now this is new.
No, this short stroke length.
Yes, sir. The new engines are having very shorter stroke length as compared to the older engines.
Yes.
How is it done now?
Actually, the stroke length has some bearing on the piston speed. If you look at the piston speed of an engine, you know it is 2 ln by st. Sorry, I don't know if the equation is right, but you can easily calculate. That is, you take the time it takes to move one forward and one backward stroke, one revolution. From that you can calculate the piston speed. And if you look at, I just tried to calculate all the piston speeds of all the cars that exist today. You find that almost all of them have a mean piston speed in the range of about 11 to 13 or something like that, meters per second. And if you increase the mean piston speed, then friction losses go up, and the wear and tear also goes up, life of the engine also will come down. So one way to reduce the engine piston speed, mean piston speed, is to reduce the stroke. Or if you increase the engine speed, you have to reduce the stroke so that you can keep the mean piston speed under control. So it is a relationship between this, that is the necessity to bring down friction, necessity to bring down wear, that you go in for shorter strokes.
Okay, thank you. For the center, just see Lakshmi Devi Institute Alwar is good. Lakshmi Devi Institute Alwar.
Any question from Lakshmi Devi Institute Alwar? At least please respond if you are listening.
Lakshmi Devi Institute.
If you don't have any question, at least tell us that you don't have any question. Hello?
Question is that the composition of air is much different from what it is in the standard consideration. So don't you think that there should be some sensors which should actually look at this so that the air fuel mixture is also changed, the ratio is changed?
Because in daytime, no number of vehicles are there. Air concentration in the pollutant concentration is something different. Morning something different, evening, and sensors which are sensing the quality of air and then adjusting air filtration.
Like there may not be significant change in the composition of the air. It is not so drastic that it affects the combustion and all that, because generally we assume that oxygen content in the air is around 20.9% or very close to 21%, and this small, because the pollutant level is, it is in ppm level, or it is 0.1%, 0.01%, so that does not make much difference on the quality of the content of the composition of the air. So I think they don't affect this, and this concept is not being even practically insignificant for the engine management system.
What about the use of nanotechnology to reduce exhaust emissions?
Nanotechnology concept has been used in the filtration system. Like we have used nanofiber to filter the air so that we can get better quality of the air inhaling, and then micron size of the particle can be reduced. But in the exhaust system, I don't remember like if any.
People have tried nano additives.
That is in radiator. No? Nano additives they are adding into radiator coolant basically, because it is increasing the heat transfer coefficient. Yes, so size of the radiator can be reduced if you are using nanometals in the cooling circuit. No, so that is being tried. But again, problem is that nanometal life is very less, stability is very low. So within 24 hours, within 48 hours, they'll separate out from the liquid, and again. Yes, again we'll have to regenerate that one. So it's a difficult, and nanometals are very costly also.
But one application which is implemented, that is in air filtration system. Nanofiber by Mahle, it has been patented, and they are using this nanofiber in the air cleaner, and now they are trying in fuel filter also. So that is one application which is metallized.
So we can have one more question from some other institute. Last question of this panel discussion.
Any question from Mount Abu? Sir, these are all.
The second one is Alwar.
Sir, this is Mount Abu.
No, it is Alwar. It is Alwar. Mount Abu is
Lakshmi Devi Institute.
The room structure was something different.
Sir,
yes,
yes, so this one.
Mount Abu. Yes.
Any question from Mount Abu? Yes.
Hello. So you can ask your question.
Hello.
Yeah, you can ask a question.
Hello.
Yes, sir.
Sir, I am from USB College, Abu Road.
Yes.
Hello, sir.
Yes, sir. We are listening.
Sir, I am USB College, Abu Road.
Yes, please continue.
Sri USB College of Engineering, Abu Road.
Please ask your question.
Sir, my question is this: why supercharging is essential for aircraft engine? Sir, my question is this: why supercharging is essential for aircraft engines?
Okay. First, it is only for piston engines, and I think the answer is that in an aircraft engine, you want the engine to be light, you want it to be small, and the supercharger develops more power for the same engine size. So the engine size can be reduced. In the case of an aircraft engine, are you able to hear? Are you able to hear us?
आवाज जा रही है, कुछ आवाज आ रही है।
सर आपको आवाज आ रही है? Are you listening?
Yes, sir. Yes, sir.
Yes, please continue.
So in the case of an aircraft engine, we require a very compact engine with a small weight, and a supercharged engine normally develops high powers, so it is compact. and it is also light. So that is why in aircraft engines one would prefer a supercharger, particularly in piston engine. But you know that those SI engines.
Engines have gone
So SI engines are difficult to supercharge. So there are problems.
Another one, at higher altitude, density of air is also less, so we'll have to increase the density here.
That is a very important point. Very important.
Air density is very low at high altitude. That make supercharging a must.
So I'm stopping the panel discussion right here. Thank you, participants. Thank you, different participants at different locations. And I'm particularly thankful to the experts on the panel, Professor Ramesh, Dr. Khatri. I'm very thankful, sir. You have spared a valuable time and have given us some time for discussions. I'm also thankful to my director, who also contributed to this. Let us give them a big hand. Thank you. Tomorrow again at tomorrow 9:30, Dr. Khatri will take the session. Tomorrow 9:30 we. Thank you all.